So we are in part 2 of standard test signal. In the last video you saw about impulse, and now we'll see another very important signal which resembles a sudden change. So impulse resembles a sudden change. So it could be mathematically expressed as R of t is equal to A into U of t. U of t is a unit step input, which is a standard mathematical object. So here, so what will be R of t? When t is less than 0, output is R of t is 0. The input signal is 0, and at t greater than 0 and equal to 0, greater than or equal to 0, it suddenly jumps. So a sudden, you remember our switching on the gas stove, suddenly you are giving an input. So we want to know how things are. And when we learned Laplace transform, we have seen that R of S is A by S. So be very careful. R of S means a function of S. A by S, A is a constant, S is a complex variable, okay. So R of S is equal to, so what is a S, etc. you should think, and you should revise your Laplace transform. So basically what we are doing is, for all this analysis, the differential equation has been converted into transfer function G of S, a complex variable. R of t is converted into R of S. For step function, R of S is A by S. Another signal of interest is whose value is 0 for t less than 0 and increases linearly with time. So here R of t, what is happening to R of t? For t less than 0, R of t is 0, and for t greater than 0, it is increasing at a rate of A. So the slope will be A. So what is Laplace transform of R of t? Laplace transform of R of t is A by S square. Another signal which is of interest is parabolic signal. You can see parabolic signal here. You can see the parabolic signal here. So what is happening to the signal? The signal is as t increases, it is not increasing linearly, it is increasing at a faster rate. So it is given as R of t is equal to 0 for t less than 0. It's very straightforward, okay, there is nothing to explain here. R of t is equal to 0 for t less than 0, and it is equal to A t square when t is greater than 0. And what is Laplace transform of R of t? 2A by S cube. And for the examination, when if they ask you to explain about standard test signal, you should write impulse, you should draw the graph. You have to do three things. You have to draw the graph, you have to write the mathematical equation, you should write the Laplace transform, okay. So parabolic signal, you draw the graph, you write the mathematical equation, and then you write the Laplace transform. And as an engineering student, you should be able to write equation for any graph, and you should be able to draw graph for any equation. So to summarize, we have studied 4 types of standard test signal. Impulse, you remember, it's a spike. What is impulse? Impulse, the diagram is not given here. The impulse will be something like this, goes to infinity, and it is denoted by delta t, and Laplace transform of R of t is delta t is 1, And step function, you know, is a sudden change, not very high magnitude, say magnitude A, then R of t, the mathematically we will write R of t. This is a short form, R of t is equal to A into U of t. And the Laplace transform of this is A by S. And for a ramp, it is given by R of t. It's a very kind of simplified expression. R of t, when you are writing for the examination, it's for you to remember R of t is equal to 0 for t less than 0 and equal to AT for t greater than 0. And how is the shape? It's 0 for small values and then it will increase linearly. Parabola means, parabolic input means 0, and after that t greater than 0 it increases at a faster rate. So these are the standard tests. So these are some mathematical interesting things. If you integrate a step signal, you will get ramp. If you integrate a ramp signal, you will get parabola. And if you integrate step, you will get ramp. Integrating ramp, you will get parabola. So another thing is that if you have a step signal, if you differentiate it, you will get an impulse. Can I go to backward? So I will just, this is very interesting, impulse response can be obtained by taking the derivative of step response. So you see the step is this. So if I take the derivative, what is the derivative here? What is the derivative here when for t less than 0? There is no change, isn't it? Derivative means there is no change here. So what is the derivative here? The derivative is 0 here and derivative is 0 here also. If I take derivative here at t is equal to 0, what is the derivative? We have studied in school that dy by dt is equal to delta y by delta t. The change in time is so small, and in that such a small change in time, say 10 power minus 10, what happens to the output? It changes by 1. So 1 by 10 power minus 10 is 10 power 10. So impulse is in fact the derivative of the step, and we can get impulse response by taking derivative of step response. So to conclude, input signal to the system is not known ahead of time. You design a system, you design a car, that's a system. We don't know what kind of roads it will be traveling, what kind of people will be doing it. So it should be rugged, isn't it? It should behave well for all kinds of inputs. So we can't try it for all kinds of input. So instead of that, what will we do? We'll check whether it is good for some particular test inputs. What are those test input? Impulse, step, ramp and parabolic. And if to tell you on a lighter vein, when car is being manufactured, they will have a lot of tests. They will have a crash test. Say your mobile, let me take the mobile. So what they will do to check whether the mobile is good, they'll drop, there's something called drop test. And they will kind of hit on the screen, maybe like this with some sharp object. So they'll test all these things. So control system engineers, when they do something, they have to test for many inputs. So instead of testing many inputs, they test for a couple of inputs. And if the system is behaving well, with God's hand, or if God doesn't trouble too much, then it should behave well for all kinds of input. We mortals can do only up to a limit. So adukku mele, if something happens, it is with God. Okay. So we have to do our part, and with God.